The lesson we want to cover today is the fourth in our transformation lessons, which is a dilation. If you notice, sorry about that, if you notice, what we're going to do is take a figure and once again change something about it. Okay? So, if you take a look at the before and after pictures that I have up on the board, and if you look at ABC and then A prime, B prime, C prime, hopefully you'll notice that when I go from ABC to A prime, B prime, C prime, in both of these pictures, something has changed that we haven't seen before. And what's changed is the size of our figure. If you think about when you have heard the term pupils dilating, and not pupils being students, but your eyes, okay, what that means is that your eyes get either bigger or smaller. Now, let's go through a few definitions. A dilation is a transformation in which a figure either stretches or shrinks. Okay? That's what we mean by changing the size. Now, the center of dilation is the fixed point of dilation. If no point is given, then it is the origin. If a point on the figure is given, or of the figure, is the center of dilation, then similar to a rotation, that figure will not change, or that point will not change. Then that point will not move or change. Now, the terminology used for a dilation is what's called the scale factor. And simply, well, not so simple, but it will be simple. The technical definition of scale factor is the ratio of a side length of the image. And hopefully you'll remember that ratio means to compare numbers or compare things using division, okay, to the corresponding or matching side length of the original. In notation form, the way we write it is that x, y get multiplied by some constant k, and k is the scale factor. Now, thinking logically, if k is greater than 1, it's going to enlarge the figure. If k is greater than 0 but less than 1, so a number like a half or a third, then it shrinks it. We're not going to deal with negatives in this course. So let's take a look at a couple of examples. And they are pretty straightforward. Now, I'm going to take this original quadrilateral and I'm going to dilate it with a scale factor of 2. The only way to do a dilation is to take the original coordinates, A, B, C, and D. So -3, -2, -1, -2, -3, -5, and -1, -5. And what am I going to do to it? If the scale factor is 2, I'm going to double each coordinate. So A prime, -6, -4. B prime, -2, -4. C prime, -6, -10. And D prime, -2, -10. This is the only way to do this dilation. Okay, I can't count spaces like I did before. So I'm going to plot the original. So -3, -2 is A. -1, -2 is B. -3, -5 is C. And there is D. Now to find the image, all I can do is plot my 4 new coordinates. So -6, -4, -2, -4, -6, -10, and -2, -10. There is my A prime, B prime, B prime, C prime, D prime. You'll notice the order of the coordinates don't change. The only thing that changes is the size. So for example, the length of segment AB is 2 units, while the length of segment A prime, B prime is 4. Well, that makes sense. I doubled the size of the figure. Let's go to the next example. I'm going to take this triangle and dilate it with a scale factor of 1/2. So my original 3 points of A, B, and C are -8, 4, -6, 6, and -4, 2, -2. That's XY. So what am I going to do? I'm going to take X and Y, multiplying it by 1/2 is the same as dividing by 2. So what's A prime going to be? -4, 2. B prime, -3, 3. And C prime, -2, -1. Graph the original. There is A. There is B. And there is C. And then do the same for A prime, B prime, and C prime. Oh, a little too far down. And you're done. Okay, so let's go through the last 2 examples. Now I give you the before and after picture. So the blue is the after because it's marked with the primes, and the red is the before because it doesn't have the primes. Now you might say to yourself, well, wait a second, I can't count any of these sides. They're all diagonals. That's correct. But it's actually very simple. A was the coordinate 2, 1, and it became the coordinate, let me just put A prime there for a second. It became the coordinate 4, 2. Well, how did I go from A to A prime? I multiplied by 2. So that's my scale factor 2. The other way to look at it is the image to the original. Well, the image is a unit point of 4, while the original was 2, and that's another way to get the scale factor. Okay? Now I go, oh, sorry about that. When the orientation's off, it gets a little screwy and it doesn't want to cooperate. Now I go to my last example. Same thing, but I give you the coordinates. So I went from C to C prime. Well, hopefully you see that the numbers got smaller. So that means my scale factor better be less than 1. Well, how do I figure it out? I'm going to take the image and divide it by the original. And it doesn't matter which 2 coordinates you use, or which X or Y, whichever one you use, as long as you don't mix them up. Image is 2, original is 6, so my scale factor was 1/3. Last question, is it an isometry? The question we've been asking at the end of every lesson. hopefully you're going to say, no, size changes. So our last transformation was a dilation. A dilation either shrinks or enlarges a figure by some determined scale factor.